Hey everyone, welcome back. In our last video we talked about frequency distributions, both looking at them as tables and as bar charts and histograms. Distributions are an important concept because they tell us that not all of our values are in the same position. This is going to be really important as we think about applying more sophisticated statistical analyses to analyzing our data. The first moment of a distribution is critically important and one that students are already familiar with. That is central tendency. With central tendency, you're asking, what is the typical case in our data? I say typical because there are different ways to measure that central point. Most students are already familiar with the three main ways we measure that central point. The three M's. We've got mean, median, and mode. We're going to talk about them in reverse order, though, in this video. So mode refers to the value of the variable that occurs the most. We've already seen the mode in our frequency distribution tables. The mode tells us the most commonly occurring value. It tells us really then the peak value in our distribution. We look at our bar charts or histograms, we can easily identify the mode by looking at the point which the frequency or count is the highest. This is going to be really important when we start thinking about variance around that peak. The second way to measure central tendency is the median. The median, as a review for most people, simply refers to the middle value of our data when our data are ranked. So once again, if we have a continuum of data, let's say from 0 to 100, our median value will be the value in the midpoint of that data array, where 50% of the values are below that median point and 50% of the values are above. Now, the median is a concept that most people are familiar with, but the real importance for the median comes from the fact that when we start thinking about medians, we start thinking about positioning in our data. Once again, the median is the 50th percent point of that data distribution. And a lot of you are already familiar with percentiles. 10th percentile, 20th percentile, 25th percentile, SAT scores, GREs, standardized testing is all kind of talked about on being on a distribution with these critical juncture points, these percentiles or positions. So once again, the median is the 50th position or the middle position of that data. We can start thinking about other positions as well, like the 25th percentile, the 75th percentile, or perhaps even the 68th or 95th percentiles. So positioning in the distribution is critically important to the way we think about statistics. Finally, we have the mean. The mean is simply the arithmetic average of all of our values in our data. To calculate the mean, we simply add up all of our values and we divide by the number of observations. Now, the one thing that's critically important about the mean is that the mean is really vulnerable to outliers. Outliers are extreme values on one end of the continuum or on the other end of the continuum. We'll take a look at all this stuff in a couple examples. All right, so here we have our usual data. We've got our 25 students, our class standing, our averages, our grades, and our grade num. Let's first look at the mode. The mode is simply the value with the highest frequency or the highest count. So when we look at class standing, we see that the highest count is 10. However, in this case, we can see that both first-year students and sophomores have a count of 10. In this case, we would call the distribution bimodal since there are two modes. If a distribution only has a single mode, we call that unimodal, and if a distribution has three or more modes, we refer to that as multimodal. We can observe the modality very easily by looking at bar charts or histograms. Here's the bar chart of class standing. We can compare this to a unimodal distribution like grades. Here we can see from our frequency distribution table, there's only one mode, C, which has 10 observations. That's higher than B's, 9, A's at 4s, and D's at 2. This is clearly observable in the bar chart where C's clearly have the highest peak. Identifying the mode for continuous data is also straightforward, although a little bit more laborious. Instead of creating a frequency distribution table, here I'm just presenting the histogram. You can see here from the histogram that we have a mode probably somewhere in the 75 range. It actually turns out if we look at our snapshot of data, 76 is the mode with a frequency of 4. Let's turn our attention to the median. Note here that medians require that the data are rank ordered from lowest value to highest value. Therefore, medians are not appropriate for dummy variables or for nominal variables. Medians should only be calculated for ordinal variables and continuous variables. Here I'm using the continuous variable for grades. You'll see here that I've already ranked the grade variable from lowest to highest value. The easiest way to figure out the median value is to take the number of observations, add 1, and divide by 2. That number will give you the observation number that is the median in your data. Since our data here have 25 observations, we take 25 plus 1 divided by 2. That gives us 26 divided by 2 for 13. The 13th observation is the median. This makes sense because 50%, 12 of our observations, are below the median. 12 of our observations are above the median. That gives us 12 plus 12 plus 24, plus the median value gives us our 25. If you have an even number of observations, the same rules apply. You're still going to take the total number of observations, add 1, and divide by 2. Let's suppose we have one less observation in our data here, and we only had 24 cases. We would take 24 plus 1, that gives us 25, and divide by 2. That would give us the medianth observation as 12.5. Since there's no 12.5, we would have to then take the observation that occupied the 12th position and the 13th position and average them out. The average of those 12th and 13th positions would give us the 12.5th value for the median. Let's turn our attention to the mean. Here's the formula for the mean. On the left-hand side of the equal sign, we have x with a bar on top. X stands for any random variable we want to calculate the mean for, and the bar stands for the mean. We set that equal to 1 divided by n, where n is equal to the number of observations. Keep in mind that if we multiply something by 1 over n, it's the same as dividing by n. In the parentheses, we have a giant sigma sign. Sigma means add. It's telling us to add every observation of xi starting at I equals 1 all the way through n. In other words, sigma xi simply says add all of the values of x. We're going to multiply all the values of x by 1 over n, which is the same as dividing by n, to calculate the mean. In other words, once again, this simply means add all the values of x and divide by n. Let's look at our calculation with our grade data. Here, once again, we have the average scores from our sample student data. In order to apply the formula, we're first going to solve for the sum of xi. Here, we're simply going to add all the values of x. We're going to add 60 plus 69 plus 70 plus 72, all the way down to 90 plus 93. Once we have all of those values summed together, which gives us 1987, we're going to plug that 1987 back in our formula, which is multiplying it by 1 over 25, which is equivalent to dividing by 25. In this case, once we divide 1987 by 25, we get an average of 79.48. So the class average score is 79.48. Finally, let's look at the effect of outliers. Suppose that in addition to our 25 students who completed the class, we had 2 students who received zeros. If we had those 2 zeros, which are pretty far away from the rest of our observations, we had a new average of 73.59. This underrepresents the performance of the class by including those outliers. So to sum up, modes are useful for categorical and for continuous variables. Modes help us identify the most commonly occurring value in our data set. Our data can be unimodal with 1 mode, bimodal with 2 modes, or 3 or more modes, which we call multimodal. The median values help us identify position. The median is the 50th position or middle position in our data. We can think about other values in reference to that midpoint. Finally, the mean is the arithmetic average of all of our values, keeping in mind that the arithmetic average is vulnerable to outliers. We'll continue on with our discussion of how this all relates to frequency distributions by looking at dispersion in our next video.